Hello everyone. In the last video, we discussed about convolutional layer. In this convolution layer, if you remember, we are given an input image of, let's say, size of n cross n, and in convolution layer, we'll be having something called as kernel roll filter, which is used for extracting out some specific feature and which will be of size something like k cross k. And you guys already know what is the convolution operation. The convolution operation is simply placing this kernel on the input image and try to do element-wise multiplication and then followed by some addition. Okay. On doing this operation, we'll be getting some values, and those values will be placed in the output feature map. And as I said, the input size is n cross n over here, and kernel size is k cross k. And finally, the output size when we are using some kernel like this will be n minus k plus 1 cross n minus k plus 1. And if you remember, as I said, this kernel or filter will be able to give only information of one specific feature. So this feature map will be having information of only one feature. Okay. But in some real-time example, there will be multiple features. Like if you are taking some human face, there can be multiple features like ears, eyes, nose, teeth. All those will be features, right? For all the separate features, we'll be having separate such kernels. So let's say this is the kernel that is for ear, and there will be second kernel. Like if it is for left ear, then this will be for right ear, and there will be another kernel that is for nose, and there will be some other kernel that is for teeth. Like that, all the features will be having separate kernels, and these kernels can be uh, equal to the number of features that we wanted to extract out of the input image. And finally, after having all the, let's say the number of kernels is, for suppose it is m, then the overall shape of these whole kernels or filters will be k cross m. And similarly, as I said, if you see, this output is corresponding to only this particular kernel, right? Similarly, as we are having these many number of kernels, we'll be having those many number of output feature maps as well. That means this is the second feature map that we get by doing the convolution operation. And similarly, we'll be getting the third feature map by doing convolution operation with this third kernel. Okay. And similarly, fourth feature map with fourth kernel. Like that, we'll be getting even output of shape n minus k plus 1 cross n minus k plus 1 cross m, where this m represents the number of kernels, because each kernel will be giving one output feature map of size n minus k plus 1 cross n minus k plus 1. So I hope whatever I'm trying to tell in this particular video is clear till now. Now let's move on to the next layer, that is ReLU layer. If you guys remember, we have discussed about ReLU in ANN videos itself. ReLU is simply an activation function. Have you guys remembered what is ReLU activation function? In ReLU activation function, whenever the input to this function is positive or 0, it will remain the same, that is x. When it is less than 0, it will be 0. Okay. This is the ReLU activation function. Now, if you see the graph of this, it will look something like this. Let's say on x-axis we are having x, whereas on y-axis we are having ReLU of x. Then the corresponding graph, if we plot, then for negative, when x is negative, the ReLU of x will always be 0. But when x is positive, it will be increasing in the same ratio with respect to x. So like this, the overall graph will look like. Basically, if ReLU is not applied, then this line will extend like this. If you see, this is some kind of a linear line. Whenever we are giving some line equation, what is trying to do? It is trying to add some non-linearity by bending this line like this. So it is bending this and making it like this so that it adds some non-linearity. So that's why we say that this ReLU layer will add us some non-linearity, which will help us in extracting out complex features out of the input image, and also it can do it better than simply applying convolution and then pulling. If you do ReLU in between, it will try to clearly extract out the important information from the input image. If you guys remember, in this particular output feature map, we can have values that can be positive, or those can be even in negative. So let's say here there is some negative value. On that, if we apply ReLU, then that will become 0. And if there is a positive value, that will be left as it is. And if you guys remember, I also said that if there is a feature, this feature is exactly present in the input image, then according to our discussion, at that particular place, let's say there is an exact match at this position, then at this position the value will be higher. Like if you are doing normalization on the input image and doing the convolution operation, then the highest value can be +1. And similarly, when there is a complete mismatch, the least value will be -1. So now by applying this ReLU, we are neglecting out all the negative values. That means all of them we are making it to 0, because in negatives, if they are going, they are not important information to consider. That's why we are directly making it to 0, and then we are using them, which will help us actually in getting out the results better. Okay, so that is what ReLU layer will be doing. For ReLU layer, the input will be this one, that is this particular output feature map that we got out of convolutional layer. And on this, when we apply ReLU, what will happen? Just that on passing it through ReLU layer, whenever there is a negative value in this feature map, it will be making it to 0, and remaining positive values, they will be left as it is. And will this particular dimensions of the output feature map will change? What do you guys think? It will not change, because we are just changing the values, but remaining everything remains the same, right? So here also we'll be having output feature map of size. So this is the total output feature map that we got out of ReLU layer. It will also having the same dimensions, that is n minus k plus 1 cross n minus k plus 1 cross m. This is about ReLU layer, and it helps us in better feature extraction. Okay, so that's it for this video. In the next video, we'll be discussing about pooling layer and how it is helpful for us. Thank you everyone. Bye bye.